Hello and welcome to our lesson here for today. You should have a notes page from the teacher, so if you do not have that, please make sure you get that before you continue on. It has specific blanks and fill in the blanks and things there for you to help you out on your notes today, so make sure you have that. And once again, just like normal, it will be looked at in order for you to receive the practice assignment, so please make sure you are taking notes as you are watching this video. Today's objective, you have two pieces to our objective here today. Our objective is that you all, the mathematicians in this classroom, will be able to determine whether a relation is a function, as well as being able to find the domain and range and use function notation. So once again, make sure you are following that on your notes and filling those in as we learn about these objectives today. So first of all, we do have some vocabulary words. I do have a vocab section for you on the notes. You will notice that these are some of the words and some of the other vocabulary words we will get to later. The first word is relation. A relation is a pairing of numbers in one set with the numbers in another set. The pairing of numbers in one set paired with other numbers. This is a relation. Some people think about it like a relationship, two things together. In the definition, it does use two other vocabulary words, domain and range. So a relation is a pairing of the numbers in the domain paired with the numbers in the range. And that's often represented as an ordered pair. So then it tells us, okay, well, what's the domain and range? So a domain is the set of x values, so the first value in an ordered pair, and the range is the y value, or the second number in the ordered pair. That will always be true. Domain is the x value, range is the y value. So as we've been kind of introducing functions here the last couple of days, we haven't specifically defined what is a function. So an extremely essential piece of understanding is knowing what a function is. A function is a special type of relation, so a pairing of numbers, a special type of relation in which each value in the domain is paired with exactly one value in the range. And today in our lesson, you are going to see multiple ways to show and demonstrate and prove that a relation is a function. Okay, so in order for it to be a function, the domain is paired with exactly one range. The input gives one exact output. So as we look at this, all right, we have problem number one. We've got identifying, or we have ordered pairs. It's asking us to identify the domain and range in the relation and then represent it using something called a mapping diagram. Okay, so let's take a look at what that looks like here. When I am first looking at domain and range, domain is the x value in each ordered pair. So the -2, the 0, the 4, and the 5 are all part of the domain. So I'm actually going to go ahead and write those down here. And then I also have in my second piece here, I have my range. Switch to yellow. My range is the 0.5, the 0.25, the 6.5, and the 2.5. So once again, I'm going to list those out over beside here. Now, as we continue here, we can go ahead and piece this all together here. So I have my domains listed on the left. I'm going to label them with a D above. And then I have my range listed over here. So I have identified the domain and the range of each relation. Then I need to actually do the mapping diagram. So what I have listed here is actually already the beginning of my mapping diagram. My mapping diagram is a way to show which range each domain is paired with. So the domain of -2 is paired with 0.5. 0 is paired with 0.25. I apologize for my error there in my writing. 0.25 0.25. 4 is paired with 6.5, and 5 is paired with 2.5. Okay, so here I have a mapping diagram. A mapping diagram is simply a way to show the range that each domain is connected to with arrows. Now, a way to actually say then that this is a function. Remember, the rule for it to be a function is that the domain is paired with exactly one value in the range. So because each domain has its own range value, and I do not have domains duplicated, I do have a function. Okay, so let's take a look at another one here in part B. In part B, we have 6, 5, 4, 3, 6, 4, and 5, 8. So I'm first supposed to identify the domain and the range. So first, my domain is again the first number in each ordered pair, and the range is the second value in each of the ordered pairs. So then I'm going to go ahead and start making my mapping diagram. Now, something I did not do on the first one that I probably should do, and we should do as we continue forward here, is writing our values from least to greatest. So I have 6, 4, 6, and 5. So I'm going to write 4, 5, and 6. These are my domain values. And then I've got my range values over here. I have 5, 3, 4, and 8. So I'm going to again write those in order. 3, 4, 5, 8. All right, so as I look at this, now to create my mapping diagram, the domain of 4 is paired with the output or the range of 3. The domain of 5 is paired with the output or the range of 8. And then I have 6 paired with 5 as well as 6 paired with 4. So here I have my mapping diagram showing the relation between each of these domain and range values. But something now that I have that is different than in part A. In this one, I have 2 values that are paired with a domain of 6. 2 values that are paired with the domain of 6. Because of that, this domain does not have one range value. This domain of 6 has 2 range values, and that means that it is not a function. Another way to think about this, when you first learned about functions in previous years of math, you sometimes may have heard a teacher refer to a function machine or some kind of function equation. So when you put the number 6 in for x, the reason that this is not a function is because the mapping diagram that we have shows that one time when you plug 6 in for x, you got the answer of 4, and that a second time when you plugged 6 in for x, you got an answer of 5. What that means is we do not have a true function because it did not come out the same each time. Typically, when you put one value in for a variable, it should always work out to equal the same thing. So that is one of the ways to remember this if that helps you. Okay, please take a look at these 2 got it questions. Again, you've got places on your notes for all this, so go ahead and try this out. It does ask for a mapping diagram as well as stating if it is or is not a function. And then when you are ready to check your answers, please resume your video. All right, welcome back. Here are the answers. They're down there on the bottom right. I hope that you can see them. For number 1, we have not a function because the 4.2 is a domain twice and has different ranges, and that is not a function. The second one, part B, it is a function, and again, you can see those mapping diagrams in the bottom right-hand corner. So let's continue on here. We do have another vocabulary word, the vertical line test. A vertical line test. If any vertical line passes through more than one point on a graph, the relation is not a function. So this is another way to visually represent the domain having one range value or more than one range values. And that is what this is called, the vertical line test. So how can we actually use this, apply it, and better understand it? Well, here we go. Is the relation a function? In part A, you will notice that we have our ordered pairs up there at the top. We know that the domain is the first value, the range is the second value, but we're going to specifically focus on the graph. The vertical line test is when you look at each vertical line. I apologize, my highlighter is a little too thick there. But when you look at each vertical line that is on your graph, I'm not going to highlight everyone, otherwise I'll just have the whole graph colored. But when you look at each vertical line, the vertical line test looks at each vertical line on the graph and determines, is there one point on that line or are there multiple? If there are multiple points on any one vertical line, then that means we have a repeated range, and that means that we have not a function in front of us. So this is not a function here in part A, because on the first and the, well, only the first one, I'm sorry. On the first vertical line, we have 2 points that have the same range, and so that does not create a function. In part B, you'll notice that as we look at each vertical line, so no matter which one we look at, all of them only have 1 point on it where that line crosses the vertical line, and so this passes the vertical line test, showing that we have a function. All right, so you need to take a look at the got it questions. Once again, on your notes paper, you've got places to look at this. Notice you will need to perform the vertical line test, so make sure you are showing that. And when you are done, resume your video to check your answers. All right, welcome back. Your answers here. A is a function. It does pass the vertical line test. And part B is not a function. It does not pass the vertical line test on the 0 line or the y-axis. All right, so let's keep going here. We do have another vocabulary word on our hands, the function notation. So you've seen functions represented with equations involving x and y. So y equals negative 3x plus 1. But we have something called function notation where we say and write f of x, or f appears to be being multiplied by x, is equal to, and then the rest of the equation is the same. So the f of x replaces the y. The letter f is the name of the function. It is not a variable, so this is function f. We might have function w or g or s, but that first letter is not a variable, it's a name of the function. So this is function f. Function notation is used to emphasize that the function value depends on the independent variable. So this function notation specifically highlights that independent variable for us and shows us that the value of the function, or the name of the function f, that depends on what we put in for x. Okay, so let's take a look at this type of notation. In problem 3 here, the function w of x equals 250x represents the number of words, wx, you can read in x minutes. How many words can you read in 8 minutes? Well, in order to solve this problem, I am looking to figure out how many words in 8 minutes, and I do see that it says x is minutes, so I am going to go ahead and plug in 8 for x. So my w, my words, with 8 minutes is going to be 250 times 8. So when I do 250 times 8, I get the w of 8, or the function with an 8 plugged in, gives me the value of 2,000. So my answer here is that this person can read 2,000 words in 8 minutes. All right, go ahead and take a look. This got it question does refer back to problem 3's function, but I did copy it into this problem for you. So use the function from problem 3 to determine how many words you can read in 6 minutes. When you're ready to check your answer, please resume your video and I will give you the answer. All right, welcome back. For this got it question, you should have gotten an answer of 1,500 words when you plug in 6 minutes. So let's continue on here once again. In question number 4, finding the range of a function. So when it gives us a domain, f of x equals negative 1.5x plus 4, and it has the range being 1, 2, 3, and 4. We are supposed to, it gives us a domain of 1, 2, 3, and 4. I apologize. We are supposed to find the range. So in order to find the range, we need to make a table and plug these domain values in order to find the range that matches. So this table might look familiar to a couple of days ago. I believe on Wednesday we looked at these tables. We have our x value, we've got our equation, and then we've got our range or our y values. So when I plug in the first value, 1, negative 1.5 times 1 gives us negative 1.5, and when we add 4, we get 2.5. When I plug in 2, negative 1.5 times 2 plus 4, that gives me a range of 1. When I plug in a domain of 3, I end up with a range of negative 0.5. And when I plug in a domain of 4, sorry, I ran out of space here, I end up with a range of 2. So when it's asking me to find the range, it's simply asking me to plug in the domain values for x and find the y value or the range. So our range here is 2.5, 1, negative 0.5, and negative 2. And typically if it is some kind of multiple choice question, you are listing your answers, they do typically write them down from least to greatest. All right, so please go ahead and try this got it question, and when you are ready to check your answer, please resume your video and you can check your work. All right, welcome back. Your answer here should have been negative 8, 0, 8, and 16. If you are not sure how I got that, please ask, and I'm happy to help you with that. And our last piece here for today, identifying a reasonable domain and range. You have 3 quarts of paint to paint the trim of your house. A quart of paint covers 100 square feet. The function AQ equals 100Q represents the area, or AQ, in square feet, A of Q, sorry, that Q quarts of paint covers. What domain and range are reasonable for the function? And then what is the graph? So as I look at this, I know that 1 quart, it says a quart of paint covers 100 square feet. And I have 3 quarts of paint. So as I'm thinking about the area that I will be able to paint, I'm thinking that my area is probably going to be no more than 300 square feet, since I already have an estimation of a quart is 100 square feet and I've got 3 of those. So I am keeping that in mind as I look at my domain and range values and thinking about what is reasonable. It is not reasonable for me to be trying to paint 500 square feet with these 3 quarts of paint. So the least amount of paint I can use is none, so the smallest domain value is 0. I have 3 quarts of paint, so I can use 1, I can use 2, and I can use 3. It is possible for me to be using half of a quart or something like that, so when I'm graphing I will have some other answers that appear there as well. So as I look at this, all right, I have that table already here for us. The quarts are 0, 1, 2, and 3, and we already thought through the square feet that it will cover. And then our graph is graphing those points, and notice that it is a continuous graph, not a discrete graph, because I can use partial cans of paint and paint any amount of area up to 300 square feet. So my domain values, that make sense in this situation, are 0, 1, 2, and 3. My range values that make sense in this situation, that make it reasonable, are 0 through 300. And then the graph, like I said, is there. So once again, we've got one more got it question. Please go ahead and give this a try, and when you are ready, you can resume your video to check your work. All right, here are the answers to that got it. When you are finished checking your work, once again, if you don't understand, you should ask a question, but if you do understand, at this point we are at the end of the lesson. So the objective, I hope that you have met the objective and that you have a better understanding than when you began. You are hopefully able to now determine if we have a function, whether a relation is a function, and then using function notation as well as finding the domain and range. So please show your completed notes page to the teacher to get your practice assignment.